In this video, we are going to learn how to solve for a missing angle, which is really cool. So we have a new type of function. You're used to seeing sine, cosine, and tangent, but just as square roots have their opposites, squaring, so does sine, cosine, and tangent. And that would just be sine inverse, cosine inverse, tangent inverse, or inverse tangent, and they have multiple ways of showing up. The most common is probably sine inverse with like the -1. Sometimes it's arcsine. They mean the exact same thing. But I'll use the little -1 type symbol over here. So how do they end up getting used? Let's just talk through a few examples. Our task is to solve for angle x. So on this triangle, that would be right here. So I'm going to remind myself by putting a theta in that corner that's the angle that is the reference angle. When you don't know your angle, that becomes the reference angle. So x is the reference angle. That means 5 is the opposite side and 9 is the adjacent side. And I don't have a hypotenuse length given to me. But that's okay, because I only need 2 sides to find an angle. O and A go with tangent. Tangent of theta equals the opposite over the adjacent. Well, I don't know what theta is, so I still have tangent of theta equals, but I do have O and A, 5 and 9. Now what I need you to remember is that tangent is not a number, it's a function. So you have to do the inverse operation. And the inverse of tangent is tangent inverse. So to get rid of tangent, I have to do the inverse, right? I'm trying to get theta by itself, so I have to do the same thing, tangent inverse. Tangent inverse undoes tangent, so it gets rid of it. And now I have theta equals tangent inverse of 5 over 9. This is on the same button as your tangent button. It's in small writing above it, so you have to press second tangent, and then it gives you tangent inverse. And so if I put in tangent inverse of 5 divided by 9 in my calculator, it will tell me that the angle is 29.1. It says to the nearest degree, so I'll do 29 degrees, right? Nearest degree. There we go. That's all it comes down to. So let's do another one. This time we're going to find angle n. So I'm going to put theta in the corner for angle n. I'm going to label my sides. I have a hypotenuse and an adjacent side. H and A go with cosine. Cosine of theta is A over H. So cosine of theta will be 1.1 over 5.2. Once again, we're finding the angle here. So I have to undo cosine. So I'm going to do cosine inverse of both sides, cosine inverse. And now I have theta, right? Cosine inverse undoes cosine. So theta equals cosine inverse of 1.1 over 5.2. All right, I'll type that in my calculator. Second cosine, which gives me cosine inverse of 1.1 divided by 5.2. I get 77.78, so if I were to round that, that would be approximately 78 degrees for theta. All right, let's do one more. Angle Z is my reference angle, theta, so across from that is the opposite, and I have the hypotenuse. O and H go with sine. I know sine of an angle will give me the opposite over the hypotenuse. Or in this case, sine of my missing angle equals 17 over 22. I will do, you guessed it, sine inverse of both sides so that I can get theta by itself. So theta is sine inverse of 17 over 22. I'll type that in my calculator. Inverse sine of 17 divided by 22 is 50.599, so that rounds up to approximately 51 degrees. So notice that when we are solving for an angle, we're going to use inverse functions. Okay, solve for an angle, use an inverse. If we're not solving for an angle, then you're using regular functions. Thanks for watching.